Heat transfer mode. Heat transfer is the transport of energy due to the temperature difference between different amounts of matter. Is the transport of energy due to a temperature difference between different amounts of matter. We know that an ice cube taken out of the freezer will melt when it is placed in a warmer environment, such as a glass of liquid water or on a plate with room air around it. From the discussion about energy in the previous section, we realized that through chapter 2, we realized that the molecules of matter have three types of energy: kinetic energy, translational, energy, kinetic energy. The second one is rotational and vibrational. Is third, rotate energy and vibrational energy. Energy in these modes can transmit to the nearby molecules by interaction or the change of the molecules, such that energy emitted by molecules that have more on average to those that have less on average temperature. So energy can be transmitted to nearby molecules that have more on average by interaction or by exchange. Or by exchange of molecules, such that energy is emitted by the molecules from higher temperature to lower temperatures. This energy exchange between molecules is heat transfer by conditions. By conduction. This energy exchange between molecules is conduction. And it increases with the temperature difference and the ability of the matter substance to make it apparent. To make a transfer. Did this description come with a conduction mode? The amount of the heat transfer expressed in the Fourier log Q dot equals to giving the rate of heat transfer as proportional to the conductivity. K is conductivity, A is area, at the temperature gradient. Fourier law. The minus sign indicated the direction of the heat transfer from a higher temperature to a lower temperature. Minus sign is indicated the direction of heat from higher temperature to lower temperature. Often the gradient is evaluated as a temperature difference divided by a distance when an estimate has to be made if a mathematical or numerical solution is not available. Value of conductivity are on the order of 100 for the metals, order of conductivity for metals 100 1 to 10 for the non-metallic solid such as glass, one 10 to 10 for liquids, around 1/10 for insulation materials. And 1/10 down to less than 1/10 to less than 100 for gases. A different mode of heat transfer takes place when a medium is flowing, called convective heat transfer. When a medium takes place, is flowing. In this mode, the bulk motion of substance moves matter with a certain energy level over a near surface with a different temperature. A bulk motion of substance moves matter with a certain energy level over or near a surface with a different temperature. Now the heat transfer by conduction is dominated by the manner in which the bulk motion brings to the substance in contact or close proximity. Examples are the wind blowing on over a building, all flow through heat exchanger. Which can be air flowing over through a radiator with water flowing inside the radiator piping. The overall heat transfer is typically correlated with the Newton's law of cooling as Q dot equals AH delta T. Convection heat H is convection coefficient convection heat transfer coefficient A is area Delta T is the temperature difference between the matter and the bulk. And fluid bulk. A more detailed study of fluid mechanics and heat transfer aspects of the overall process is necessary to evaluate the heat transfer coefficient for a given situation. Typical value of the coefficients. Convection coefficients are typical values natural convection, H equals to 5 to 25 watts for gas, and for the liquid H equals to 50 to 1000. Liquid, we have also another four-state convection, H equals to 25 to 20 for gas, and H equals to for liquid. Boiling phase change, very high H occurs in boiling applications. The final mode of heat transfer is radiation. The final rate which transmits energy as electromagnetic waves in space. Transmits energy as electromagnetic waves in space. The transfer can happen in empty space and does not require any matter. but the emission of the radiation and the absorption do require a substance. Generation or absorption a substance to be present. Surface emission is usually written as a fraction emissivity of a perfect black body emission. So if it a perfect black body emission as epsilon, the heat transfer radiation can be write Q dot epsilon sigma ATS4, where with the surface temperature and the sigma is Stefan Boltzmann's constant. Typical value of emissivity range from epsilon is emissivity and A is the area. And emissivity for the non-metallic non-polished metallic surfaces and for highly polished metallic radiation is distributed over a range of wavelengths and it is emitted and observed differently from different surfaces, but such a description is beyond the scope of this book. Comparison of heat and work is the next one.